Context and beginning of Emirates Flight 521. On August 3, 2016, a Boeing 777 of Emirates prepared to depart from Tiruvananthapuram Airport, India, heading towards its hub in Dubai, carrying a total of 300 people, including 282 passengers and 16 cabin crew. This flight, in theory, was a routine journey within Emirates' extensive network, but right from the first minute, the crew and the aircraft would face a series of consecutive challenges, where every decision and maneuver could directly impact the safety of both the crew and the passengers. The flight deck crew consisted of 2 pilots with impressive flight records but who had never directly coordinated before. The captain, 34 years old, a UAE citizen, had over 7,000 flight hours, including 5,000 hours on the Boeing 777. He was considered proficient in operating this aircraft type, familiar with standard procedures, and capable of handling complex situations in the cockpit. The first officer, 37 years old, an Australian national, possessed 9,000 flight hours, with 1,200 hours on the 777. He had performed numerous long-haul flights and was also evaluated by colleagues as having the ability to control the aircraft steadily and accurately. Although the first officer's total experience was higher, the coordination between the 2 pilots had never been directly tested, which would play a crucial role in the flight's unfolding events. Departure preparations were carried out according to standard procedures. The aircraft underwent technical checks, and the pilots conducted a detailed briefing on the flight path, landing parameters, and contingency measures in case of changes in weather conditions or technical malfunctions. The flight management systems, automated and manual devices were all checked, from the speed and altitude settings to the landing mode, flaps, and landing gear. Warning systems were also confirmed to be operational. The crew understood that although this was a routine journey, any error in operation, any data discrepancy from the automated systems, or any unexpected weather condition could lead to a dangerous situation. Therefore, every action was performed under strict procedures, with each step confirmed via control panels, display screens, and continuous communication between the captain and the first officer. The departure time was on schedule. The aircraft was pushed back from the gate, and air traffic control monitored and coordinated the takeoff path. Everything proceeded within the expected time frame, with initial speed and flight path being stable. Coordination among the crew, the automatic systems, and ground control was tightly maintained. However, despite no obvious anomalies at this stage, the foundation for a series of serious incidents was quietly forming due to the flight deck coordination that had never been practiced together and the aircraft's complex automatic mechanism, setting the stage for life or death decisions in the minutes that followed. Within the first half hour, the flight proceeded as planned, with the pilots maintaining stable flight modes, preparing for the approach and landing phase in Dubai. This is the context, foundation, and complete beginning for the story of Emirates 521's incident, where every technical detail and pilot action would become a matter of survival in the next minutes. Emirates 521's weather and landing preparation. As the Emirates Boeing 777 approached Dubai, the crew noticed that conditions at the airport were far from simple. The temperature at that time was up to 48 degrees Celsius, the highest of the summer, causing the runway surface to be scorching hot, forming columns of strong warm air that directly affected the airflow around the aircraft's wings. Furthermore, the wind in the area was constantly changing with the risk of wind shear, strong gusts of wind changing direction and speed over short distances, potentially causing the aircraft to be abruptly lifted or dropped, altering the runway approach path. The pilots were well aware of this inherent danger. Before landing, they conducted a detailed briefing, agreeing on the approach and landing plan. They prepared for the contingency of a go-around and aborted landing, a procedure requiring precise coordination between the 2 pilots, with one controlling the aircraft and the other monitoring the systems, ensuring the plane achieves the correct speed, altitude, and wing configuration to climb again. Parameters were preset: approach speed, landing angle, flap settings, and most importantly, the automatic mode TOGA, takeoff/go-around. This mode allows the aircraft to increase engine thrust and automatically set flight parameters for a safe climb. Simultaneously, they also set the minimum go-around altitude, ensuring that if an abort was necessary, the aircraft could climb to the correct safe altitude, avoiding collisions with objects on the ground or other aircraft in the airport area. Additionally, The crew had to combine information from air traffic control and reports from preceding pilots regarding wind speed, wind direction, and runway conditions. Although radar and wind measurement systems provided data, the pilots still needed to compare them with reality to assess wind speed at markers near the ground. This was a crucial step because wind shear often appears unexpectedly at low altitudes, where warning systems might be limited. All preparation maneuvers aimed for one goal: to ensure that despite adverse conditions, the crew could either execute a safe landing or immediately perform a go-around without losing control. They did not rely solely on feel or personal experience, but had to operate the aircraft according to procedure, check equipment, set parameters accurately, and remain ready to react in every second. Even before the plane touched the runway, the situation presented a dual challenge. Wind gusts and high temperatures combined with a landing path requiring precise control. The captain and first officer had to maintain speed, direction, and monitor every change in system data, preparing all reactions if wind gusts or temperature changes altered the wind pressure. Everything was calculated beforehand, from approach speed to go-around reactions, but the coordination between man and machine remained the decisive factor. Emirates Flight 521, although starting normally, entered the critical phase where every maneuver would put the crew in a life-or-death situation, preparing for the next tense moments as it approached the scorching runway and unusual wind gusts of Dubai. Emirates 521's approach and landing phase. As the Boeing 777 entered the runway approach phase, all prior preparations had to face a harsh reality: constantly changing wind and high temperatures increasing the airspeed around the wings. Under these conditions, the aircraft began to exhibit a float phenomenon. It did not decrease altitude as planned but hovered, drifting further down the runway than expected. This was not a minor issue. Floating made it difficult for the plane to touch down at the correct point, meaning the brakes and deceleration systems had to work harder, and the landing path would be inaccurate, posing the risk of overshooting the safe portion of the runway. The aircraft's warning system registered a delayed landing. The long landing warning, a signal that the aircraft has passed over 1/3 of the runway length, immediately illuminated in the cockpit. This is a serious warning, indicating that if the landing continues, the aircraft risks not having enough runway to stop safely. Pilots are trained for an immediate reaction. Go around, and aborted landing becomes the only option to ensure safety. The issue was not just speed and trajectory. When floating occurs, the constantly changing wind intensity causes fluctuations in wing pressure, forcing the pilots to continuously adjust to maintain the standard landing angle and speed. They had to coordinate closely with the preset automatic toga system, ready for the go-around contingency. The long landing signal was not only a warning but also a reminder of any minor calculation errors in the previous trajectory. Failure to react promptly could have severe consequences. In this moment, the captain and first officer operated the aircraft as a single unit. Every maneuver was considered: increasing engine thrust, adjusting wings and flaps, monitoring the speed of descent to the runway. They had to continuously evaluate data from sensors and radar to ensure the aircraft did not exceed the safe point. Any delay or miscalculation would cause the aircraft to drift past the halfway point of the runway before touchdown, implying the risk of an unsafe climb or not enough length to stop. Float and the long landing warning are evidence of objective challenges that any crew might encounter. It is not related to personal skill or luck, but a direct result of physical conditions. Wind gusts, high temperatures, and an approach path requiring absolute precision. Within seconds, the pilots had to execute accurate reactions, operating the aircraft according to the defined procedure to ensure the capability for a go-around if needed. Every factor, speed, altitude, trajectory, wind intensity, became a variable of survival. When the long landing announcement sounded, the crew had no option but to prepare for a go-around, turning a risky landing situation into a precise control operation for every second and every meter on Dubai's scorching runway. This was the turning point where technical preparation and cockpit coordination were truly tested. The error in Emirates 521's go-around. When the long landing warning sounded, the Boeing 777 crew reacted quickly. The captain commanded a go-around according to standard procedure. Increase engine thrust, raise the nose gear and wings, preparing to climb away from the runway onto a safe trajectory. In theory, every step was accurate following training. But a crucial detail was overlooked in the decisive moment. the two main landing gear wheels had touched the ground. This rendered the toga system and autothrottle, which automatically increase engine thrust during a go-around, inoperative. The engines remained at idle mode, meaning the lowest thrust setting. When the captain raised the gear and wings, the gravity and lift from the wings further decreased the aircraft's speed. The crew, focused on adjusting the aircraft and monitoring the trajectory, did not realize that the engines had not reached maximum thrust. In a few critical seconds, these factors combined in a way that all pilots are trained to avoid, but it happened. Speed decreased, lift was insufficient to pull the aircraft out of the dangerous trajectory, and flight path control became limited. Go around, in theory, is the ultimate safety measure when a landing fails, but here, it was constrained by the interaction between the main gear touching the ground and the automatic system. This phenomenon was not merely a technical fault, but a consequence of aviation systems operating as designed under specific conditions. When the wheels touched down, the autothrottle understood the aircraft was in a normal landing state, thus not activating the increased thrust. The crew, focused on climbing and monitoring the runway, had no clear signal warning them about the engine's actual power. The situation became tense, where every maneuver had to be combined with remaining data from speed, altitude, and wings. As a result, the go-around, the action designed to salvage a dangerous landing, had its effectiveness limited. The aircraft did not gain altitude as quickly as expected. The speed was insufficient to maintain a safe trajectory, and reduced lift made control more difficult. This is a classic example of how, in aviation, standard, safe maneuvers, if encountering unique physical conditions, can become a factor that complicates the situation. The error here was not related to personal skill or lack of experience. It stemmed from the combination of the automatic system design, the state of the landing gear touching the ground, and the immediate reaction in a volatile environment. This moment proves that even the most standard procedure can fail if the physical conditions and automatic systems are not fully considered. In these crucial seconds, the crew faced a challenge: how to control the aircraft while the engines had not reached maximum thrust. Speed was decreasing, and the runway below was slowly receding. This technical error and system misunderstanding was the turning point leading to the subsequent chain of events, where every reaction had to be calculated within the range of every meter and every second on Dubai's scorching runway. The danger and impact of Emirates 521. After realizing the engines had not reached maximum thrust, the situation on the Boeing 777 became so serious that it could be measured in seconds. The aircraft was at an altitude of only 85 feet, about 25 meters, with rapidly decreasing speed, nearly reaching a stall state, where the wings no longer had enough lift to keep the aircraft flying stably. This is a danger level that any experienced pilot knows, where every decision must be accurate, and a 1-second slow reaction can lead to irreversible consequences. The captain immediately pushed the throttle levers to maximum and activated toga to perform the go-around, but the flight path and the aircraft's weight had set physical limits. The small delay in realizing the engines were at idle mode meant the aircraft's speed was not sufficient to increase before contact with the ground. When the aircraft hit the runway, the wheels were immediately destroyed, and simultaneously, the engines sustained enormous impact forces, forcing the plane to slide on its belly. The left engine rotated out of its original position due to the extremely strong impact force, clearly demonstrating the uneven distribution of the collision force. This moment was the combination of multiple factors: decreasing speed, insufficient engine thrust, main gear impact, and gravity, along with lift from the wings. When the aircraft crashed onto the runway, the systems designed to protect the aircraft in minor impacts were no longer sufficient to maintain the structure and key components. The damages were instantaneous, evident, and severe, creating a situation that the crew had to deal with immediately while quickly assessing the next steps to prevent further damage and the risk of fire and explosion. The Emirates 521 situation shows that in aviation, a small delay in realizing the engine status can become the decisive factor leading to a collision. The automatic system, standard procedures, and pilot skill are all important, but when physical factors meet at the limit, the result can become severe regardless of experience. The aircraft's wheels were destroyed, the engines were damaged, and the aircraft structure was compromised while sliding on the runway. These damages were not only a direct consequence of the impact, but also reflected the complex interplay between aircraft design, automatic mechanism, and human reaction. Each factor combined to turn a standard, well-trained go-around into a dangerous collision. Evacuation and human casualties of Emirates 521. Immediately after the terrifying impact, the passenger evacuation process became the absolute priority. All 300 people on board, passengers and cabin crew, were directed out of the aircraft, but not all escape doors were functional. Only 3 out of 10 doors could be used, creating a bottleneck at the available exits and forcing the crew to manage the passenger flow with extreme precision. The escape system on the Boeing 777 is designed to cope with fire and collision, but the mechanical damage from the impact limited the effectiveness of most doors. This was why the evacuation, although fast, still faced obstacles and required tight coordination between the crew and ground rescue forces. Rescue personnel at the scene intervened immediately, deploying fire extinguishers, assessing the condition of the damaged wheels, wings, and engines to prevent the risk from spreading. Fire broke out from the engine and the aircraft belly, but thanks to the quick response of the fire brigade, the fire was controlled within a short time. However, the danger persisted. One rescue worker died due to debris from the right wing flying out while approaching the dangerous area, and 4 cabin crew members were severely injured during the evacuation, proving that in emergency situations, the boundary between safety and risk is very fragile. The survival of all passengers was the result of a series of factors: the crew's timely reaction, the professionally trained evacuation procedure, the readily available ground rescue forces, along with the emergency-designed escape mechanism. This situation emphasizes that, even in a severe collision, if systems and people coordinate effectively, significant loss of life can be avoided. This process also shows the practical limitations of aircraft design and rescue procedures. When only 3 out of 10 escape doors were available, controlling the flow of people, identifying the still functional exits, and maintaining discipline on board became paramount tasks. The crew had to continuously assess the situation and make rapid decisions, ensuring everyone exited the aircraft safely under conditions where the risk of fire and explosion remained high. Lessons and changes after the Emirates 521 accident. The Emirates 521 accident became a significant milestone in modern aviation, not only because of the extent of physical damage or the risk to human life, but also because of the strategic lessons learned about people, procedure, and automation. Immediately following the incident, Emirates made drastic changes in pilot training, particularly emphasizing the ability to perform a go-around after the aircraft has touched the ground. Previously, procedures focused on altitudes above 50 feet. Now, pilots must be ready to activate a go-around even when the landing gear has contacted the runway, to minimize the risk of repeating a similar situation. Furthermore, training on pilot monitoring and recognizing errors caused by automation was enhanced. Emirates and other airlines realized that, in many cases, highly skilled pilots could still encounter incidents if they misunderstood the automatic systems. The aircraft's failure to react correctly when TOGA was activated during the Emirates 521 incident is clear evidence. The aviation industry was compelled to train pilots to determine the actual status of the engines, the automation mode, and the system limits, rather than merely relying on screens and warnings. Concurrently, information about wind shear from air traffic control in previous flights was improved, providing accurate, timely data on wind speed, direction, and sudden changes became a crucial factor for the crew to make a landing or go-around decision. Emirates coordinated with air traffic control to ensure that warnings about wind gusts and dangerous conditions were communicated fully, clearly, and accurately to the pilots. The accident also highlighted the risks associated with automation. Modern systems can optimize flight performance, but can also lead to misunderstanding the aircraft's actual state. A pilot who misinterprets a situation due to automation can create catastrophic results, despite good personal skill. This forced the aviation industry to balance technology and human factors between system reliability and the pilot's ability to react promptly. In addition to training and procedures, the Emirates 521 event also spurred a reevaluation of cabin design, escape mechanisms, and emergency management. Every detail, from go-around capability to fire response, was meticulously reviewed to ensure that, when risks